Hi, I'm Mr. Evans, and in today's video it's going to be a brief introduction to forces, and in particular all we're going to talk about in this video are 6 different types of forces that we will work on throughout class. Now, some of these forces are way easier than others, and so I'm going to go ahead and start with those. And for example, one force that I think we are all familiar with is the force that opposes motion. And so if I have some kind of object here, and let's say it weighs 10 kilograms, and it is moving in this direction, I'll do movement as a red arrow. So this is just movement. The force that opposes it and makes it eventually slow down, and why everything that you throw comes to a stop, is due to our friction force. And so one type of force is friction, and force 1b, just because it's also basically a type of friction, would be if that same object was flying through the air. And so let's say you throw a football through the air. The same thing as friction, just in the air, is drag, which is also sometimes referred to as wind resistance. And so our first type of motion is drag or friction. And this motion always has to go against the way the object is moving. So if I have my object again, and it is moving to the left, then our friction force, which is written as F of F, because the big F is force, the little f is friction, will be to the right. And this applies even in a scenario where the object, let's say, is moving to the right, but its acceleration is backwards, and so it's slowing down. The friction is still the opposite direction. Our next force I want to talk about, which I think is also another easy one, is gravity. Okay, this is one people tend to forget about because it's just always there. And so, in a huge, shocker here, gravity is always pointing down. And so when we talk about F of G, we're talking about gravity, and it's pulling an object down. So whether it's sitting on a ledge or flying through the air, gravity is pulling it down. The only exception to this would be if an object was actually in outer space where gravity is not occurring. Our next force often cancels out the gravity force, and it is called the normal force, and this is another one people tend to forget about. And so if I have an object sitting on the ground here, and gravity is pulling it down, well, guess what? According to this force diagram right now, that object should be collapsing into the center of the earth. But it's not. It's not moving. It's sitting on, let's make this into a table. Okay, so if this book is sitting on a table, it's not moving. And so the force that's canceling out the gravity force is called the normal force. Okay, so normal force often cancels out the gravity force. And the normal force is the force that this desk is applying to the book. And so if gravity is pulling down, the desk is pushing back up with the same amount of force to keep it there. Okay, so this normal force can only apply if an object is touching something else. And so, again, if an object is in the air and not touching anything, there is no normal force. One other instance of normal force that's worth talking about is, let's say we're on an incline, so there's some type of ramp here, and we have our box again. Okay, so again, let's use different color. Gravity is always pulling down. However, the normal force is always perpendicular to the plane that it's sitting on, and so over here it was straight up because our plane was perfectly left to right. Well, this one's slanted, so our normal force is actually off at an angle. Okay, and so that is normal force. This leaves us with our last 3 forces that are significantly less common, and honestly I'm pretty terrible at including in examples, but we do need to mention them because they could be talked about. The first one is tension force. Okay, and so tension typically has to do with anything tied to a rope. So again, if we have our box here, and there's a rope here that's attached to the ceiling, Okay, our tension force is canceling out gravity again. So gravity is pulling this box down, but it's not falling down because it's held up by this rope. And so with an equal amount of force, there is tension force. And this applies to anything. So you can have ropes, you can have cables, anything like that. You know, like an elevator, for example. If we were all standing in an elevator. Elevators are held up by cables. And so this would also be tension force, where gravity is pulling down and tension is canceling it out by pulling back up. The next force is magnetic, and so magnetic occurs depending on if there's, you know, like or opposite charges occurring. And so in this case, if I have a magnet over here and a magnet over here, and I have two like charges, you know, our magnetic force is going to be pointing this way. All right, they're going to repel each other. Versus if I change this and make one of these into a negative magnet, then our forces are going to come towards each other because the object is accelerating towards each other because like or opposite charges attract. The final force we're talking about is electrical force, and so I'm not sure how to really draw this and make it look too much different than the magnetic force, but just be aware that things can also have electrical charges that are positive and negative. And I think of this when it comes to atoms a lot just because of my chemistry background. And so if I have an electron here and a proton in the nucleus of a charge, these are oppositely charged, and because of that, they attract. Versus, you know, if I had two electrons floating around in the atom, these are both negatively charged, and so because of that, they repel, and the forces indicate that. And so if these electrons up here started moving closer together, eventually their electric charges would actually accelerate them in the opposite direction. And so these are the 6 different types of forces that you're going to be expected to know. And by expected to know, I mean you should be able to apply them in a scenario where you can draw out a force diagram, solve for acceleration, and stuff like that. Now we haven't covered that yet, but moving forward you will have to use these forces to solve for those types of questions.